Good afternoon. My name is Sean Michael. I'm on faculty at the University of Colorado. And I got interested in this topic through working with Rosh Review. So there's a disclosure there, but the topic and the content today is really agnostic to brand. Because really what I want to talk about is fundamentally the power of scale. So we've traditionally thought about online question banks as a study tool where our residents or our students can go and learn something about content. And I want to flip that today. I want to think about this as an analytical platform where we as educators can go to learn something about our learners and learn something about the macro system in which we're delivering education, where we can really do something great with the data that we have available to us. So we're going to look from a couple levels of altitudes. I'd like to introduce Pat to you. Pat's a PGY2 resident, and we'll look at things from the perspective of Pat the learner and Pat's program, and also the system in which Pat's program operates, this system of all of us. Because since elementary school, Pat has been acculturated to believe that 100% is the goal on a spelling test, on a high-stakes exam, on a question bank. And it's Pat's job to do more questions and get more questions correct, because after all, the percentage correct is just the number of questions you got correct divided by the total number of questions. But it turns out that that data point is very information poor. And we can really do better, because from Pat's perspective, looking at the questions that Pat answers in a question bank, 4 to 5 questions correct, 80% sounds reasonable. But we've made a fundamental error in our assumptions in calculating that. And the error is one of independence of observations. Because the reality is, Pat's not alone. We've calculated the performance as a percent correct for a number of different learners. And we've done it only across rows. And we're assuming that each person is seeing unique questions in isolation. That's not true. So we're making calculations across rows, but then we're comparing learners across columns. And that's not a valid comparison. And of course, they're not seeing questions in isolation. A question bank that has 10,000 questions in it might have 48 million question impressions where a question has been seen. So in a small data world, Pat and Alex may have gotten 80%. But in a big data world, question 1 doesn't matter that much because everybody got it correct and doesn't help us differentiate between learners. And question 3 and question 5 might provide duplicative information. And a couple of questions may discriminate really well between learners with a high performance and a low performance overall. But both of these folks got 80%, and they have opposite results on these 2 questions. So all of this has to mean something. But my human brain is too small to pick through the spaghetti and really find the patterns. But fortunately, machine learning algorithms are sophisticated enough that they can do some of that work for us. But remember, we've only been talking about an example of 4 learners and 5 questions. But you can do this at scale, right? Across 50 million questions from 67,000 learners. And then all of a sudden, you have something very powerful to tell Pat about how to intelligently target his or her study. And if you're Pat's program director, then you can draw confidence intervals around estimates of each learner's actual knowledge, and you can target interventions, and you can provide early warning, and you can individualize education. And you can aggregate that information, which means that you could look across learners in your program, and you can map out where the program itself is having places of underperformance. And then you could improve those areas. And if you were an education scientist, you could look at the entire universe of programs. You could look at the macro system in which we deliver medical education, not just to compete on who's better, that's fun, but to see where the gaps are and where we need to improve as a specialty and where we need to look across specialties. And then you could deploy interventions, and you could measure the results of those interventions at scale, because most of the PATs of the world are using question banks anyway. So we can be using those question banks as an experimental platform, not just a content delivery platform. And all that means that we as a community of academic emergency physicians need to think bigger about this. We can use these platforms for educational effectiveness research, not just for pushing content to learners in a passive way. So we can take advantage of this scale because it's already deployed. The technology is already out there, and we can use big data to target and measure process improvement on the process of education. And then we need to teach our learners, people like Pat, how to think beyond just a goal of 100%, and how to think about engaging in targeted lifelong learning in a measurable way. And we can do that. We have the tools to do that. We just have to decide to do that. Thanks very much.